In this lesson, we're going to write the complete and net ionic equations. The equations we've looked at so far are molecular equations. They show each substance written as the formula for the compound. We're going to then change that into a complete ionic equation and then simplify that into the net ionic equation to show what is actually changing in the reaction. In the molecular equation, which we see an example of at the bottom, the formulas of the compounds are written as though all species existed as molecules or whole units. It doesn't actually show us the change that is happening, and chemistry is all about exploring the changes that substances undergo. From the molecular equation, we can write a complete ionic equation. And when we do this, we show any dissolved species as free ions. So those substances which are soluble in water, and those are indicated by the AQ or for aqueous. We have NH42S aqueous plus copper nitrate aqueous. So we can break those up into the ions and we get NH4 plus, S2 minus, copper 2 plus, and NO3 minus with the appropriate coefficients for balancing. Next, we're going to look at what we get for the products. For the product side, what we see happening is the NH4NO3 is aqueous, so we're going to write that as ions. However, the copper sulfide is a solid. And when we have a solid or something that's insoluble in water, it will not dissociate into ions in solution, and so we leave that as CuS with a solid phase. And this is our complete ionic equation. Anything that's aqueous is shown as an ion. Any solids or pure liquids are left as the compound. To get from the complete ionic to the net ionic equation, then we have to eliminate spectator ions. And so these are ions that do not change from the left to the right side of the reaction. Let's look at our example and see the things that are not changing. We'll start with the NH4 plus, which does not change from the left to the right. It's an aqueous ion on the left and an aqueous ion on the right. Therefore, it is a spectator ion. The same can be said for nitrate or NO3 minus. It's a nitrate ion aqueous on the left, and it's exactly the same on the right. So that is also a spectator ion. What we see left are the sulfide ion and the copper ion, which change from ions in the aqueous phase on the left side to a copper sulfide solid compound on the right side. So there's something changing there as that precipitate forms, and that precipitate comes out of solution. So what we're left with is our net ionic equation. And these are the species that are actually involved in the reaction. They're actually involved in something that's being changed. And we're left with our net ionic equation with the sulfide plus copper yielding copper sulfide. The other ions are still there, but they're remaining as aqueous ions in solution and they don't undergo any change. So the reaction shows only those species that undergo some kind of change. To write a net ionic equation, we have three steps. We write a balanced molecular equation for the reaction. Next, we rewrite the equation to show the dissociated ions in solution, so those things that are soluble or with the aqueous phase, and that's our complete ionic equation. And then we identify and cancel out spectator ions, and what we're left with is the net ionic equation.